Hi there, Kim Coach Powers here. Today we're going to be talking about some household applications of acids and bases. All right, so this is section 9.3 in your text. Let's go ahead and get rolling here. All right, acids and bases in the home and salts. Recognize several acidic and basic items commonly found in the homes and describe the cleaning action of soap, detergent, and bleach. Especially, I'm going to focus on the cleaning action of soaps and then a little bit of what detergents are. So cool to see how this stuff works from a chemical standpoint. All right, so why do we add cleaning products to water? Well, water doesn't mix with grease and oil, right? Because grease and oil are nonpolar and water is polar. And so cleaning products are put into water so that they can improve the ability of water to mix with oily substances to create some emulsions. Soaps allow oil and water to mix. Soap is a substance that is used as a cleaner and that dissolves in water. It can dissolve in both oil and in water. This is so cool about soap. And again, you're going to see this in some of my pictures here in a second. But soap dissolves in both oil and water, which means that it is a perfect blend between the two worlds of polar and nonpolar. Soap allows oil and water to form an emulsion that can be washed away by rinsing. Detergents. So what in the world is a detergent? Well, a water-soluble cleaner that can emulsify dirt and oil. It's a little bit different than a soap. Typically, a detergent is going to be man-made, and it's going to have longer chains, and it works a little bit better. A lot of times, detergents are going to have the ability to reduce the soap scum. Okay, so soaps are going to form scum, which will show what that is here in a little bit too, with magnesium and calcium, especially also iron. And soap scum is an insoluble salt, which means that it kind of builds up, and we'll talk about what that looks like. But the detergents are going to have an additive put into them, which will basically absorb all those magnesium and calciums, so you don't end up losing or having that soap scum. Hydrocarbon chains are in detergents, and they come from petroleum products. Okay, so soaps are typically made from animal fats or plant fats, plant oils, but the detergents are made from petroleum products. So a little bit different in the way that they interact with nature as well. So here's an example of a soap molecule. Soap molecule, you can see, has a nonpolar tail. That's where all those little carbons are all strung up with their hydrogens, and then a polar head. Remember, when we talk about polarity, polarity has to do with the... Oh, I lost my... Oh, there we go. Come back, buddy. Polarity has to do with that charge, right? So we've got this charged part of the molecule. We call it the head of the molecule. So we have this tail and we have a head. So let's look at what that kind of looks like. So here's our polar head. It's got the charged sodium on it. It's got a big positive charge and it's got some negative charges there. And then all of this basically is what we consider our non-polar tail. So that's a soap molecule. Now, where do we get a soap molecule from? Well, we can start with fat. Okay. And we can treat it with a substance called lye or sodium hydroxide. And what ends up happening is we break it up, and you can see that we now have these soap molecules. Okay, because the sodiums are right here. All right, and then we have the tails that are kind of right here. So what's left over, we have a glycerol molecule that's also part of that. But this is where we get soap from. Okay, now a synthetic detergent looks a little bit different. Remember, we said that they had longer chains. Well, notice how long this chain is. Whoa, right? We got a long chain of the nonpolar parts. The nonpolar tail is a little bit longer, which makes it a little bit easier or a little bit better at grabbing on to other nonpolar things. And then we still have polar heads. Okay, so detergents also have the polar heads and the nonpolar tails. These are salts. Remember, we talked about salts before? This is one of the salts we talked about, sodium lauryl sulfate. So these can be the result of an acid and a base coming together. And again, where did I get the Na from? Well, remember I said it's lye or sodium hydroxide. Remember, that's a base, right? And so we could have this acid that reacts with the base, and we end up with this substance here. So these are synthetic detergents, again, made from the petroleum products. All right, so soap made from animal and vegetable fat, and sodium hydroxide, detergent made from petroleum products. We've given you some examples and some pictures of those already. You know, detergents you're going to find in your laundry, right? Soap, your laundry detergent, we call it. And sometimes you're going to have some detergents in your, you know, shampoos and things like that as well. If you're looking at soap that's like the bar soap that you use in the bath or the shower, that's probably really going to be made from animal fat or vegetable fat. Whoa. All right. So how does it remove the grease? Let's go into this. Again, this is one of my favorite things to talk about. It's so cool to watch this stuff attack it. So here's our nonpolar side. Now our nonpolar part is actually noticing, I don't know if you noticed, but this piece of dirt here is all attacked by the nonpolar sides. And then the polar parts of our soap molecules are all sticking on the outside. So it's kind of like putting all the polar stuff on the outside. Well, look, what's on the outside is all this water. And so the water grabs on to the polar part, and the dirt is grabbed onto by the nonpolar part. And so once you take the water and wash it away, all this stuff just kind of goes with it. Isn't that wild? Isn't that cool? And it makes these little mycelials, these little bubbles of soap kind of surrounding with all their tails surrounding the dirt particles. And so why do we rub our hands? Well, we want to increase the number of contacts, right, that the soap is having with the dirt. And so that's going to allow for more collisions, and that's going to allow for the contact to allow it to separate out. So here is a picture of a pipe that has hard water in it. Okay, this chunk right here had hard water in it, not anymore. And so this chunk is probably just a bunch of calcium that has deposited over time. So basically imagine this is limestone, okay? So this calcium carbonate deposit has slowly built up over time, and so the pipes will actually get filled up and corroded if you have pipes that are, you know, running in a place where there's hard water. And that's the soap scum, basically. Okay, if you feel that soap scum on the sides of your bathtub or your shower, if you're using soap, you'll get this scum that you can, you know, spray and it can come off, but it's reacting basically with the minerals in the hard water. That's the soap reacting with those minerals, and it forms these insoluble salts that don't go anywhere. And so that's why you have to spray a particular, usually another type of cleaner on top of it to get rid of those insoluble salts. Again, the reason that detergents aren't forming these insoluble salts, they have sulfonate ions, okay? And those are less likely to bind to calcium than the carboxylates. And also some detergents are actually mixtures, and they'll actually have additives like sodium bicarbonate, and that works as a softener. And so it binds up the calcium, and then the detergent's able to work because of that. So a couple of reasons why those detergents might work better and not give you those insoluble salts. So what is hard water? Well, hard water is water that contains a large amount of calcium and magnesium ions. So here's our soap molecule, and it's got the sodium ion, and what's happening here? Calcium is coming in, all right? Well, calcium has basically 2 electrons it can give up instead of 1 electron. Sodium only has 1 electron to give up. So what happens is that every time you pull a calcium ion in, which is calcium is going to be in the hard water, then it binds up 2 soap molecules. So instead of having the sodium together with the nonpolar tail, now the calcium is connected to the nonpolar tail. Well, that's no good. That's the insoluble salt that basically is soap scum. And so what we do is we do things like add sodium. Okay, here's our sodium bicarbonate. We add that sodium to, oops, I was erasing there. We add that sodium carbonate to our detergent. And what happens is the calcium is like, oh, okay, I'll take the place, or maybe magnesium does it. I'll take the place of the sodium on this part here. And so that frees up these sodiums. So these sodiums are now free. Now, when those sodiums are free, they can go and become part of that soap molecule again. Okay, so now here's my little sodium head and my nonpolar tail. Because that sodium came out and was freed up, now it can be a part of that soap molecule again. So we put sodium carbonate and 2 detergents like your Tide or whatever type of material, laundry detergent you use, and you're going to see that it frees up the sodiums to be part of the soap molecule again. Now, you might have, especially if you live in the mountains and you have hard water, you might have one of these in your house. Might be under your sink. This is something that is going to take hard water and basically turn it into soft water, okay? So it's got all these little resin beads inside. So here's one of those resin beads. And notice that this resin bead has got a bunch of sodium ions attached to it. So when your water comes in and your water has these calcium and magnesium ions on it, then what happens is it starts replacing the sodiums that are on these little resin beads. And so now we have calcium and magnesium on the resin bead, and that freed up our sodiums to go off and become part of that soap molecule again, allows your soap to work like it's supposed to, instead of tying it up as an insoluble salt. So some of you guys actually probably have these water softeners inside your house, and it softens your water. All right. So anyway, way cool stuff. Love the whole functioning of soaps. And let's go ahead and finish off this lecture by talking about a couple other cleaning products and other things that are in your house. One of the other cleaning products that you have is a base, and this is called ammonia. If you guys have ever smelled like Windex, that smell is typical of ammonia. You can also just get like literally bottles of ammonia. It's a diluted form of it, but then you can use that as a cleaner too. But boy, does it have a strong smell. And this is basically something that will clean away some of the lighter grease smears. Bleach is another chemical product you have in your house, which is also a base. And the point or the function of bleach is to try to whiten or make lighter certain things. It basically is a stain remover, right? Now, when we say stain remover, we have to be careful because it doesn't actually remove the material. It just changes the color, right? So we can kind of focus on this word whiten because the material is still there. Washing can get, rid of stains sometimes. But if you actually have like a grass stain, let's say, that material, you could wash your your white shirt that you got a grass stain on over and over and over again. It's going to have that green smear on it for a long time. That dye from the grass, it's not really called a dye, but that pigment from the grass, the chlorophyll just binds really strongly to your shirt and just does not come off. And so what we do is we change that pigment and we make it white instead of green, so that even though it's still there, you don't see it anymore. Okay. So what is bleach? Bleach is a compound called sodium hypochlorite. Okay. And again, it changes things to colorless forms. Makes them white and or colorless, right? We can't really say it's white. For instance, if I got a green stain on a red shirt, I don't want it to be white, okay? Because then I'm going to white stain. So no, it's actually making it colorless. We talk about whiten, but it's actually probably better to, refer to it as colorless. All right, and bleach is a great disinfectant. All right, a disinfectant is something that kills harmful bacteria or viruses. We still can't get a hold of like Clorox wipes, right, which have bleach in them. Since the pandemic, we have not been able to get a hold of those because they're in such high demand. But those are great at killing viruses. Okay, bleach can disinfect things. All right, so again, we already talked about this a little bit, but we want to remind you about this right here. Never mix bleach with any other cleaner. Why? Because it can create some dangerous gases. One of the gases that can come from this is called a chloramine gas. So don't mix this with, for instance, toilet cleaner. Some people are like, oh, I put this cleaner in here, and I'm going to put this other cleaner in here. So they've got bleach in their toilet. Then they put some toilet cleaner in there as well. Well, toilet cleaner has hydrochloric acid in it, and all of a sudden you get this green gas that starts, and it doesn't necessarily look green, but it is a green gas, and it starts to slowly come up, and it can kill you. In fact, look at this, November 7th, 2019. All right, so this is just a little more than a year ago. A manager was killed at Buffalo Wild Wings because one employee had put down Scale Clean, which was nitric acid and urea, on the floor, and later another employee put down Super 8, which was a bleach product. This created a bubbling green liquid. The manager attempted to clean and was overcome by the fumes. And so he was basically pulling this chloramine gas into his body, and it just totally messed up his lungs. Chlorine gas was something that was used in the World War I battles, and it basically causes you to drown in yourself. Basically, all your fluids come out of your cells, and you just drown in your own liquids. Anyway, this guy died later in the hospital. A lot of people go to the hospital for this. If you actually look at the number of incidences, accidental exposures to chlorine gas from mixing bleach and acid happened, for example, 2,284 times in 2017. Okay, so that's just 1 year. So a lot of people are getting exposed to this gas, and they're going to the hospital. Not all of those are dying, right? Very few of those are dying, but having to go to the hospital, being seriously, injured or hurt, and having to have a hospital stay, which costs a ton of money, is not a good thing, right? So never mix bleach with any other cleaner. Don't do it. Okay, you've been told. You've been told. Be careful. All right, so what are some other household products that contain acids, bases, and salts? A lot of healthcare, beauty, food products are going to contain these. So let's look at a couple more. For instance, vitamin C is called ascorbic acid. And you take that due to a guy by the name of Linus Pauling, who was a chemistry guy. He basically said, take vitamin C. It's going to help you with all sorts of, infirmities that you might have. Infirmary. Oh, my goodness. What word did I just make up? Infirmaries. I don't even think that's the right way to say it. An infirmary is a place you go for your infirmities. And maybe I did say the right word. Anyway, okay. So yeah, you take vitamin C. It is something that your body needs, whether or not you need it in large quantities, like Linus Pauling would suggest. That's not really been shown and proved to be true yet, but he sure is a big proponent of it. And he was a great chemist, so maybe he's got something there. Sodium hydrogen carbonate and magnesium hydroxide are also bases, basically, that you take inside your body as an antacid. An antacid is a weak base. It's going to neutralize your stomach acid, and so it's going to settle your stomach down, make you feel better. Shampoos have ideal pH. You want to make sure your pH is just right for your hair, so you're not causing damage to your hair. So somewhere between 5 and 8. Shampoo that's too basic can cause your hair strands to swell. Ooh, and then your hair will look dull and lifeless. Who knew? All right, this was a fun one. Antioxidants. Acids can sometimes be used as antioxidants. So we just talked about vitamin C. One of the uses of vitamin C and also citric acid are to sprinkle it over some of your food products that would normally spoil. Okay, so some fruits, like let's say your apples, or maybe you have guacamole, right? Maybe you've made some guacamole and it starts to turn brown. Why is it turning brown? Well, if you add some antioxidants, if you add some lemon juice to your guacamole, for instance, or some of this vinegar, citric acid, you're able to prevent that stuff from spoiling, because it prevents the oxidation process, which is what causes that spoiling look. Vinegar can be used as a marinade to tenderize your meats. Bacteria in your milk, okay? Basically, bacteria are going to convert lactose, which is a sugar in your milk, into lactic acid. That's going to change the shape of the protein, casein, and that's going to thicken the milk. Basically, you can churn your milk into cottage cheese by going through this process of acidification, and your bacteria normally do it. So when you're like, oh, gross, my spoiled milk, and you got clumps of this stuff in there, that's because the bacteria release the acid, which is causing that conglomeration. Drain cleaners have sodium hydroxide, lots of different types of products in our house that are acids and bases. So I hope you've enjoyed learning a little bit more about the acids and bases in your house. And let's see if you now can meet these objectives. Can you recognize several acidic and basic items commonly found in homes? Yeah, I think you can now. Soap, hydrochloric acid. Wait a second. You don't have hydrochloric acid in your home. Yes, you do. It's in your stomach. Your body is making hydrochloric acid. Sorry, I just threw that one in there. All right, describe the cleaning action of soap, detergent, and bleach. Wow, we got to go through really cool visuals there, seeing how soap work, seeing how it surrounds the particles of the dirt with its nonpolar tails, and then the polar heads get attracted to water and they get pulled away. All sorts of great stuff there. Hope you had fun learning about some of the common acids and bases that you have in your house. And I hope you have an awesome day. God bless you. And don't forget, be kind to one another.